Hey everyone, welcome to the R Masterclass lecture. In this lecture, we are going to look at the statistical modeling in R. So, in this lecture, we are going to look at what is linear model, what is statistical model, and what is generalized linear model. And we are going to look at some codes that how you could run this code in R for modeling. And then we are going to look at why we need to use statistical model, and then we are going to look what is the privilege of using statistical model in our language. Once that we are done with it, we are going to look at how you could use linear model formulas and generalized model linear model to create your models and train your data onto it. So let's dive into the first thing, that is introduction to statistical modeling in R. So, in simple terms, statistical model is just creating a simple representation of your mathematical model that explains that how each other variable is related. So, basically, if you have a data of area of price, right? Suppose you have a land and you have a price. So, what are the factors that affect the price? So, basically, it might be the location that which location that it is. It might fall into the criteria that in which area it is. So if you want to create some formula for it, so suppose we we could say that, suppose this is let us first me erase this. So let's say you have P, which is the price, and you want to create some formula that in which factor this price depends. So suppose this is let me erase. Basically, this is denoted by y, which is our independent value, and we say this is our price, and we want to get an idea in what factors it is related. So this could be related on to alpha factor, uh, which could be valuing from 0 to 1. Its range is would be 0 from 1, and it is multiplied by x1, and this x1 could be your price, your area, which is similarly, it might also depend on alpha 2. This could be is also range lies in between 0 to 1, and into uh, the other area could be like area, then it could be like uh, the other factors could be like condition of like land area, land area, like what the land area is in, then nearby places, all those things could be added. So this is a generalized linear model, and the value of alpha generally lies between 0 to 1. So what is mean by 0 to 1? It defines the number of like how much dependent it is. So if it's 1, so only area factor is deciding the price ratio. So this all other factor would be 0. So your alpha plus alpha 2, alpha 3 should be 1. This should be 1. The number of factors, that is number alphas are this number of factors, and this addition would be the summation of these alpha would be 1, and the alpha defines the number of dependence on the uh, like how much it's varying the price. So if it's 1, so it's wholly dependent on area factor, and if it's 0 0.5, it's like half of this uh, dependent on area factor, and it's dependent other half on the rest factors. So you get an idea like how much alpha provides, like it provide the importance for the formulas. Now we have got an idea. Let's look on to the definition. Statistical model is the process of applying statistical analysis, basically mathematical formula, to data into the order to describe, understand, or predict a phenomenon. So we generally apply this model to get an idea, okay, how this uh, trend is happening, or is our hypothesis is correct. Like if we are predicting that price depends on the area and all those factors, and in this the area factor is the much more dependent case. Is this hypothesis correct? So we could use those um, phenomenon to describe your statistical model. And basically this allows statistical modeling allows us to to check or test our hypothesis. So in simple terms, it involves creating a mathematical representation which is generally like a linear formula, that is y is equal to x1 plus x2 plus x3, and then you have alpha 1, alpha 2, alpha 3 basically. And here the y is known as your dependent value, and x is known as independent value. So y is your dv, which is dependent value, and your x is known as independent value. So you got an idea, okay, what is statistical models? Basically, it helps us to explain how other variables relate to each other. So how these variables relate to each other, that is why your price. These model allows us to analyze trends. So if we use price, remember you got an idea, okay. So we created a data visualization for price stocks ratio, like the we have a time and then we have a price for the stocks, and then we got an idea, okay, that we try to predict those trends. Now what we will do is we will use linear model to predict furthermore, like okay, on day 7, like on next day, will it be upward or will it be downward? We could use or these model to predict or analyze its trends. You could use this for COVID modeling. And in our data lecture, like in your building a project lecture, we are going to use this uh, formula to analyze this trend. Then we make prediction and test hypothesis about our data. So now it's time to look at why use statistical models. So basically the first reason is to use statistical model is data understanding. So you could uh, statistical modeling will help you understand the relationship between the variables. So basically y is equal to your equation x1 plus alpha x2 will help you to understand the relationship between the variable each other. So for example, if you uh, we have the exam score, the y variable as exam score, then these parameter is equal to would be the number of our studies, number of our studies, then number of sleep taken, number of hours played. These could be the factors that help us to determine the exam score. And using the relationship between these variable, we could try to model a equation and try to understand, okay, which influences more. And for generally speaking, you might get able to find out that the number of hours studies may be directly proportional to the exam score, and through statistical model you could able to prove this logic. Now let's look at the next one, that is prediction. So statistical model help you to predict the future values. So once you have your model determined, and remember we let me clear this. So if you remember those plots, we were able to plot till the data we have. So once we got an idea, okay, how the data lies. Suppose we have a equation like that follows this path, and we have data till this point only, that is x1 and y1. And what to do if we need to have a uh, plot more, like we need to plot for suppose x n and y n. So what we do is we could create a or statistical model. We'll try to figure out, okay, which parameter follows this line, and then we generally the through statistical model we could able to predict the future values, that is x n and y n. So suppose you want to determine the future stocks value, you want to determine the forecasting of sales or estimating risk or number of sales or your sales prediction. Generally, the statistical model is used in real life also, or and in industry level as well. Next, we have hypothesis testing. So you created a model and you want to suppose you want to find, say that okay, exercise is good for your heart rate and it reduces the uh, heart disease. So you have created a hypothesis, and to prove your hypothesis testing, the statistical model could help you. So if you able to know, like you're able to get the data for your heart rate and number of exercise taken, and then you plot a diagram over it, you might able to find out there is a downtrend in when you exercise and the number of heart rate, and your statistical model would be able to justify this reason. So if for example, does an increase in exercise reduce cholesterol? So this is a hypothesis, and how you could prove this? Using statistical model. Now, statistical model help us to assume to assumption or theories about the data. Example: does an increase in exercise reduce cholesterol? And you know that through statistical model, if you have the data, you could prove this hypothesis testing. So we have got an idea. Okay, what is hypothesis testing? And now let us look at the next one, simplification. So what do I mean by it? So by using models, we could reduce complex data into a simplified mathematical form. So basically, we have a very complex data like a heart rate or suppose we have the data of number of uh, COVID data. Using these complex data, like we have those data in huge number, and these complex data can be simplified using mathematical form, and then we could make interpretation using data visualization. So we have uh, in real life we have data in billions. So how you could do this? So basically, using mathematical equations, we are able to compose this data. Basically, there are some more things that are involved. That is basically PCA and LCA, just to remove combine those features. That is the suppose for number of for example, we have scores scored by a student in an exam, and the features are involved is study, the number of hours study, the number of hours you sleep, the number of hours you played. These are the features involved in directly to your number of scores. And this table is very complex, and suppose this data you have very huge data, so calculating for statistical model for each variable features would be very tough. So there are mathematical formula that is known as PCA, principal component analysis, which help you combine those two or three features into a single feature. So this uh, we don't have to deep dive into it, but just have to know about okay what is PC and else thing and what it does. Now we have got an idea okay what is statistical models. Now let us learn what are the benefits of using statistical models in R. Now let us look at why R is mostly used for statistical modeling. Why not use other languages for statistical modeling? So the main reason for R is used for statistical modeling because it already provides you built-in functions and libraries to train on this, and the flexibility of R for the implementation of various model, that is it's range from simple linear regression to more complex model. You could easily do this in R language. Now let us look at some key concept in our language. Now let us look at some key concepts in statistical modeling. So basically, there are two main concepts that is known as dependent and independent variables in modeling. Basically, what it is suppose if you have come across this equation, right? Y is equal to ax plus bx. So Hey, now it's time to learn about key concept in statistical modeling. So basically, in statistical modeling, there are two terms that we are need to know, that is dependent, and then there is independent variable. What it is basically we have equation something like this, right? Y is equal to ax1 plus bx2 plus cx3, like those, all those terms till xn, and it could be any numerical value ranging from 0 to 1. And basically here this is dependent on these terms, so this is known as dependent value variable. Why? Because this is dependent on these values ax plus bx plus xyz, and x1 plus x2 x3 x till xn is known as independent values. Why? Because these values do not depend on any other criteria. So these do not depend on this value. This value does not depend on x3 value. This value x3 does not depend on any other criteria. So it's known as independent variable. So the let's just look at the definition. The outcome variable we are trying to explain or predict. So basically, this is variable is the generally the outcome variable that we are trying to predict. Whether this is Boolean, might be your result would be a true or false condition. So this might could be those case, or you are trying to predict some numerical values, that could be salary. All those stuff is for the dependent variable. This is the which is independent, dependent on the independent terms. Now let us look at the definition of independent variables. Variables that potentially influence the dependent variable. For example, for salary, your one of the independent variable could be age, because there is no relationship, but there might could be age is independent of salary, because you every year you go, but salary is dependent on age by a factor x1 that we will able to calculate through statistical modeling. Similarly, for like salary, the education level is a independent variable, but for salary this is dependent on this factor. And to get the idea of how much it is dependent on, we will use statistical modeling to find out. Now in R, there are two types of generally model, basically three types, but we are going to look at those two types model. The first is linear model. Basically linear model assumes the statement to be straight line. So basically the values are basically expected to be the straight line, and the linear model is, and the values should be in this curve only. So if your data set is look like this, the linear model is best way to go. So here is your values, and this is your linear model that is trying to predict this values. So these assume a straight line relationship between predictors and the response variable. So predicting a salary based on years of experience. So basically, this could be your uh, one of the linear model line for your salary. Next, we have generalized linear model, which is extension of linear model, but it is for like if you have count data variable or some outcome to be a binary, either 0 1, then the generalized linear model is helpful. So these are the extension of linear model that handle non-normal data, basically binary data. Generally we use for binary data, that is if the result is 0 or 1. So for example, it could be used in predicting whether a patient has a disease on symptoms. So the outcome could be yes, the there will be the patient might have a disease or might not have a disease. So this is a binary outcome, and the best way to use is generalized non-linear model, GLM. Sorry, generalized linear model. Other case scenario could be, for example, weather. will it going to be rain or not. So what model going are you going to use? Yes, generalized linear model. Now there are um, we live in very in a world where everything can't be on the linear thing. So for non-linear model, basically there might be special case scenario that you might be able to find linear model, but most of the times there are chances that you might encounter with non-linear model. Basically, they might be like suppose this might be your scenario for the data set. So it might be like y is equal to x square like curve for your data set. So these capture more complex relation that can't be expressed. So this in this case scenario we need to use non-linear models, and we are going to look at the code how to use this a non-linear model. So predicting a population growth over time period with a curve. Next we need to look at how to fit a model. The basic idea behind a fitting model is to estimate the relationship in the predictors. So in R, it is often done using the LM, which is a linear model. So once we have the data set, we need to fit it onto a model. We use linear model or GLM for if you want to have a generalized linear model. If your data output is like output of the result is yes or no condition. In that case, you could use generalized linear model. These function take a formula and a data set and input output of a model that estimates the parameter like coefficient and predictor. That best explains the data. So for model, next we come to the model assumption. So while building, we have certain assumption we make while building this model. The first is uh, the relationship between the response and the predictors are linear. So basically they don't depend on each other, and this is known as linearity. So the relationship between the response, that is uh, y, and the predictor, that is x, are linear in condition. So a1 x1 b2, so these in the case they are linear, so they follow linearity. Next, independence. Observation are independent of each other. So this variable x1 is not dependent on the dependent variable. So these are the assumption made while building the your model. Now, now let us look at the process involved in statistical modeling in R. So before directly fitting onto the model, the data are not clean. Like some values might be null. So you might need to handle those. Then there might be you need to encode the data, that is like some names like Abhijit, like for animals it could be the names. So you might need to encode those data because the coding basically the mathematics way to do is just give some node name to that variable, and basically it's encoding coding, we call that encoding and decoding categorical variables. So uh, first thing we need to clean the data, right? So because we don't want any data to have null values, because if it have some null values and we are trying to fit those null values and it doesn't have suppose some missing data, so the model will not perform very well. So what is the first thing we need to do is basically data preparation. So basically we get the data and then we do what is basically we just clean the data. So what here is we are getting the age list is NA. If the data have any NA, so then replace this by mean. So one method is you just replace it with the mean. You could Another is to remove whole data. It's up to you. If you want to replace it with the mean, you could replace it, or you could just remove that data. Next, we have the model selection. So this is the next main important thing. Once you have the data cleaned and transformed, you need to select um, which model you need to use. So basically, if you need to use linear model, you could use linear model. or you need to have some binary outcomes like yes or no, you could use GLM. And if the data is non-linear, you could use NLS model. But this is very important step. So suppose if there is a data of classification regression thing, like whether it is going to be a rain or not. So what you if it's going, then this is a yes or no type of question. So if someone asks you which model you want to use, so which model you will preferably recommend to use, basically you would prefer them to use the GLM model. Why? Because its outcome is yes or no. Suppose will the student will pass or not, which model you will use? Yes, you will use GLM model because it's a yes or no type question. Next, suppose here we have a linear model. We draw some lines. Here is our variables, and suppose which model here you want to use. Basically, you will use linear model. Suppose there is some equation. Your model is like this. So you might want to use a linear model, which, because by looking at the data plot, you could see that you are able to visualize this data. It's better to use a linear model because it's following a linear path. Next, this is always not the case. There might be times that the data is on the shape of like this, and say like it's making a curve like sinusoidal curve. So which curve you might want to use? So at this time you want to use non-linear models because it will use the function fit the model and it will provide us the value. Now we have got an idea. Okay, we have used the model, we have selected the model, we have cleaned our model. Then we have to do is the model fitting. So we what do we do in this is we use our built-in function and adjust the parameter to best fit in the data. So basically what we do is we basically write this line of code, basically use linear model from the data set salary, experience plus education level and data, and the data fits into the linear regression model. And don't need to be scared, we are going to look. So you don't need, so for this, you don't need to be scared. We are in the next upcoming data visualization of linear model. We are going to look at how you could use the linear model. Now, after this is model evaluation. After fitting a model, we evaluate how it explains the data. So after we have fitted the model, we want to explain how it fits the rest of the data. So this is done through the metrics known as R square, or like standard error. Basically, it's a graph, and if it's less than 1, it shows that the data is not have been uh, properly fit. So provides a comprehensive view of model fitting and significance of predicators. Then once we have looked onto the model fitting, then we look at the model diagnostic. Okay, whether it's uh, model is fitted or not, is correct or not. So we, it's crucial to check that model assumption hold. So we plot all the data variable, we check all other curves like AIC to compare different models and their values. So once everything is validated, you don't need to worry about this model diagnostics, because very few people do that, and it just basically compares doing the all thing again but with different models. Once we have got an idea, we do the prediction. So once model is used, we need to predict the values for the latest value. So suppose we have built our model till here, our graph is we have built. So what will we do is we will create one more straight line that will be called our linear model, which will help us to predict our latest value. This is also done for the other values as well. So suppose if you have a curve polynomial graph, you could use those, and basically you will get an idea. So you got an idea, okay, how does the prediction is used. Now with this we could wrap up our lecture. So for example, let us look at one more example, that is predict model new data def. generates, what it does is basically R line of a code that is used to predict the values. Generates predicted value based on the fitted volume. Once the validator can be used to make prediction on new data. Once you have got an idea how to make prediction for the new data, then your model is done. So your statistical analysis is completed. Now in the next lecture we are going to use how to use this code line of a code in R and how to build a data visualization. So with this, I hope you have gotten understand, okay, what is statistical modeling is, what are the type of model available in this, and what are the steps we follow, what are the assumptions we made in our language. And with this, I will see you on to the next lecture. Thank you everyone.